So now let's talk about compiling with CUDA and MPI. So I've updated my matrix multiply calculation for the GPU and the CPU. I've added in MPI so that we can get our process's rank and the size of the, or the number of ranks total. I print those to the screen here so that we can see them in our output. But in this situation where we're using these wrappers that automatically include all the NVIDIA and the networking, the custom stuff, our compilation stays exactly the same. I don't have to do anything here to adjust and include those because the wrappers are already including the MPI libraries. They're already using the NVIDIA compilers. I just need to choose which wrapper, and I'm still doing C++, so I'm still using the capital CC, and I just compile the example code again. Let's go back into examples and run our compilation. And we can see right there that I have my binary. We have a submit script here, which I can run with the, again, I need to specify the project. And I want to run that in the Polaris directory so that the logs end up in the correct space. Now, with MPI, my submit script has changed. And this is a little different than what we did before in the scheduling interaction or the scheduling tutorial. When I'm submitting with MPI, I need to know how many total ranks, so how many nodes, and how many ranks per node I want to run. Very common to want to run one MPI rank per GPU. So in my submission script, I define the number of ranks per node as an environment variable that's set to 4 because we have 4 A100s per Polaris node. And I also need to know how many nodes I have. Well, PBS provides a file that you have access to that tells you the host name of every node that you have access to that you've been allocated through your request through the scheduler. Well, I can run a word count using the -L, so it's just counting the number of lines in this file, and the host names are 1 per line. So now I can have an environment variable that tells me how many nodes I have. So then I can calculate the total number of ranks by multiplying those numbers. I'm going to print those to the screen just to have a sanity check. And then I'm going to use those environment variables to submit or to execute my MPI job. So I'm on the first node of my multi-node allocation. You'll notice that in this example, I'm submitting for 2 nodes. So I've requested 2 nodes for 10 minutes on Polaris. And so I'm going to do MPI exec, and -N is telling MPI the total number of ranks that I want. And then --ppn is processes per node or ranks per node. So that's going to be that number of ranks per node environment variable that I set. And then comes my executable and any command line parameters that go to that executable. So I can run that. We already submitted our job. So now let's look at the output. So if I look at the logs and the output, you can see the bash printed to the screen, the number of nodes it determined, and the number of ranks based on multiplying by the number of ranks per node. And then we can see inside our application where we ran the matrix multiply on the GPUs and the CPUs, and then it also printed the MPI configuration information. So all of that ran correctly. And now that shows you how you can compile using these wrappers for CUDA and MPI.